There are two ways we can classify triangles. One is by the length of the sides, the other is by the size of the angle measures. Let's go ahead and look at the length of the sides. And a lot of this is probably review from junior high. The first one we have is scalene. A scalene triangle has no congruent sides. And if we were to just sketch a triangle where none of the sides were congruent, we would have to show that by tick marks, a different number of tick marks going through each side. So I'm going to have 1, 2, and 3. And if we saw that, we could say, oh yeah, that's a scalene triangle. The second type of way we could classify triangle by its sides is an isosceles triangle. And this is where at least 2 sides are congruent. If 3 sides are congruent, it can still be considered isosceles. The 2 sides that are congruent, these are called the legs. The other side is called the base. So if we were to sketch an isosceles triangle, we would want to show that at least 2 of the sides are congruent, maybe these 2 sides. Those are the legs. The other side is called the base, and it would most likely have a different length. That would be this side. There's also some special angles in an isosceles triangle. We can take a look at the angle between the 2 legs. This is called the vertex angle. So let's see where we could write that in there. It's getting a little cramped. Vertex angle, that's this guy. And then the 2 angles down by the base, these are called the base angles, and these happen to also be the same size. Just like the 2 legs are the same size, these are opposite the 2 legs, and they're on either side of the base. These are called the base angles. Okay, the third type of way we can classify a triangle by its sides is an equilateral triangle. An equilateral triangle is where you've got 3 congruent sides. So remember, isosceles has at least 2 congruent sides, therefore an equilateral triangle is also isosceles. And the way that we would show that is we would just sketch a triangle, but to make sure that we know it's equilateral, we would have to show that all 3 sides have the same length. Go ahead and pause the video right now, and at your table try to do example 1, A, B, and C. Check with your neighbors when you're done, and then when everyone's done, go ahead and press play, and we'll see if you're correct. The answers are, for the first one, this is an equilateral triangle. You may have also put that it was isosceles, which would also be correct because it has at least 2 sides that are congruent. So either would be better, but equilateral would probably be a better answer. Letter B, this is a scalene triangle since all 3 sides have different lengths, and I can see that by the different number of tick marks going through each side. The last triangle is isosceles because I can see it has at least 2 congruent sides. Let's take a look at this next example. It says, given triangle STU with vertices S is at 2, 3, T is at 4, 3, and U is at 3, negative 2. Use the distance formula, which we learned at the beginning of the year, to show that triangle STU is isosceles. So we're going to first graph these 3 points. Then we're going to find the distance between them to see if any of those sides are congruent. Let's graph it first. Point S is over 2 up 3. Point T is over 4 up 3. And U is 3 down 2. And if we connect those, get this tiny little guy. Okay, if I'm looking at this, and because it's on a coordinate grid, I know it's drawn to scale, I can kind of get an idea of which two sides I think might be the congruent ones, possibly SU and TU. But let's go ahead and prove it right now using the distance formula. So for each of our points, we've got an X and a Y. Make sure you don't get them mixed up. And we're going to find all of these. So let's go ahead and first find, I can actually just look at segment ST and I can count its length to be 2. So there's the length of ST, 2. Let's go ahead and also find the length of SU. Now remember what the distance formula says. We're going to take the square root of the difference between our x's squared added to the difference between our y values squared. So let's go ahead and plug in some numbers. Make sure that you're using the right coordinates. It'd be really easy to get mixed up since we've got 3 ordered pairs. So for SU, S and U, we're using 2, 3 and 3, -2. Our two x values are 3 and 2. Remember with the distance formula, it's cool because you can subtract the x values and the y values in any order you want, so use the way that makes more sense to you. The y values for S and U are -2 and 3, so maybe 3 minus -2. You could also do -2 minus 3, that would be fine. If we simplify this, 3 minus 2 is 1. We'll have to square that. 3 minus -2 is the same as 3 plus +2, or 5. And we'll have to square that. 1 squared is 1, 5 squared is 25. And if I add those together, we're going to get the square root of 26 for the length of SU. Okay. Now all we need to do is to find the length of our last side, which is TU. So again, we need to make sure that we're using the right ordered pairs. We're using 4, 3 for T and 3, -2 for U. If we want to subtract our x's, we're going to use x values of 4 and 3, so we could just do 4 minus 3. Our y values of T and U are 3 and -2. So maybe 3 minus -2, and then we'll simplify. 4 minus 3 is 1, we'll square that. 3 minus -2 is just like we had up there, which is the same as 3 plus 2, which is 5, we'll square that. 1 squared is 1, 5 squared is 25. If we add those, we get 26. So the length of TU is square root of 26. And I can see from my work that SU and TU have the same length. So yes, because they are congruent, this triangle is isosceles. And I can even mark that on my picture with some tick marks. Something really important that you need to remember is this next statement. The sum of the measures of the interior angles of a triangle is equal to 180 degrees. This is really important. You may have learned this in junior high. So if you add up the 3 angle measures, it will always equal 180 degrees. You could imagine this would be a way we might want to make some equations in this unit. Let's go ahead and look at the next way to classify triangles, and that is by the measure of the interior angles, or the measure of those 3 angles. So again, this part is probably a review from junior high. Let's take a look at an acute angle. This is a triangle where all 3 angles have a measure less than 90. Okay, so if we were to sketch an example, just sketch a triangle, and we would think of, you know, 3 numbers that would add up to 180 that have to all be less than 90. So maybe we choose 80 degrees, maybe 70 degrees. Okay, we're already up to 150 degrees. So we would need 30 more degrees in this third angle so that the 3 would add up to 180. So there's an example of an acute triangle. An obtuse triangle is a triangle where only one angle has a measure greater than 90. If 2 angles had a measure greater than 90, then those 2 would add up to already be more than the allotted 180 degrees that a triangle can have. And the third angle of the triangle would have to be a negative value, which doesn't make any sense. So, an obtuse triangle is a triangle where only one angle has a measure greater than 90. So if we were to sketch an obtuse triangle, let's say our obtuse angle was 110 degrees. It just has to be bigger than 90 degrees. The other 2 angles would have to add up to 70 degrees so that the 3 add up to 180 degrees. So you could think of any 2 numbers that would add up to 70. Let's just go with 50 and 20, for example. You learned a lot about right triangles back in junior high. A right triangle is a triangle where only one angle has a measure that equals 90 degrees. Again, you can't have 2 right angles in a triangle because 90 plus 90 is 180, and the third angle would have to have a measure of 0 degrees, which makes no sense. So it's a triangle where only one angle has a measure equal to 90 degrees. If we were to sketch a right triangle, the right angle is always denoted with that little square. And if that's 90 degrees, then so that all 3 angles add up to 180, the other 2 angles have to add up to 90, which also means they have to be acute. So 2 numbers that add up to 90, for example, could be 30 degrees and 60 degrees. Another thing to remember about right triangles are what their sides are called. That long side that's across from the right angle, that is called your hypotenuse. And the 2 sides that make the right angle, those are called your legs. So make sure you know those parts of a right triangle. The last type of triangle we can have when we classify by angle measures is equiangular. And this is a triangle where all 3 angles are congruent. And if you think about it, if they all have the exact same measure and they have to add up to 180, if you divide 180 by 3, that means they all have to equal 60 degrees. So if we were to draw or sketch an equiangular triangle, all 3 of these angles would be equal and they would all be 60 degrees. One thing also that's special about an equiangular triangle is that it also happens to be equilateral. So an equiangular triangle is equilateral, and an equilateral triangle is also equiangular. But if I ask you to classify it by sides, I want to hear equilateral. If I ask you to classify it by angles, I want to hear equiangular. Okay, so again, go ahead and pause the video and try to do example 3, parts A, B, C, and D by yourself. Check with your neighbor once you think you've got the answer, but you're trying to classify these triangles by their angle size. Once everybody's figured it out or thinks they understand, go ahead and press play and you can kind of check and see how you did. The first triangle, because all of the angles are congruent, this is equiangular. Now we know that this is also equilateral, but if I ask you to classify it by angles, I want to hear equiangular. You could also classify this triangle as acute because all of its angles are less than 90, so that would also be okay. The next triangle, every angle is different, but they are all less than 90, so this is an acute triangle. The third triangle, this 115 degree angle is obtuse, so just one obtuse angle makes the triangle obtuse. And part D, the triangle in part D, we see this right angle. If you see one right angle, which is all you can have in a triangle, then it is a right triangle. Let's go ahead and look at example 4. It says find the measure of the third angle of a triangle if the first angle has a measure of 66 degrees and the second angle measures 37 degrees. So if you'd like to sketch this out so you could see it a little bit better, go ahead. One angle is 66 degrees, one angle is 37 degrees. If you remember that the three angles must add up to 180 degrees, you could call this x and make an equation that would look like 37 plus 66 plus x equals 180 degrees and solve the equation for x. Or you could just add 37 and 66 and get 103 degrees and then just subtract that 103 from 180 to get the measure of that third angle. And if you do that, you get 77 degrees. If you were to solve it using the equation, you would combine these two numbers right here, which would also give you 103 degrees. This is actually just the same thing we just did. You would subtract 103 from both sides, and x would similarly give you 77 degrees. So either way is just fine, whichever way makes more sense to you. All right, in example 5, it says to find the measure of each angle in triangle RST. We have three different expressions. We've got x, 3x, and x was 40. All we know about this triangle, we don't know what type of triangle it is, but we do know that in any triangle, if we add up the three angles, it'll always equal 180 degrees. So we can make an equation to represent that. We can say that x plus 3x plus x plus 40 equals 180 degrees. If we combine some like terms, we've got 1x plus 3x plus another 1x. These three will combine to make 5x plus our 40 equals 180. We'll move our constant of 40 to the other side by subtracting it from both sides. So 5x will equal 140. And then lastly, we'll divide both sides by 5 to find out that x equals 28. Okay, so we found x. Now we need to find the measures of the three angles, R, S, and T. X is the exact same expression as angle S. So we know that angle S equals 28 degrees. Angle R is just 3 times x. So 3 times 28, which is 84 degrees. And angle T is just x plus 40, or in this case, 28 plus 40, which equals 68 degrees. And just to verify that we did everything correctly, you want to go ahead and just double check that if you add up these three numbers, it's going to equal 180 degrees, which it does. If we look at example 6, it says find the value of x. Once again, we've got an expression for each of the angles. We could say, that if I add them up, x plus x plus x, it's going to equal 180 degrees. And then when we combine our three x's, 1x plus 1x plus 1x, we get 3x. And then if we divide both sides by 3, we get x equals 60, or 60 degrees for each of the angles. But if we had been smart and kind of thought about this ahead of time, because each angle has the expression x degrees, they're all the same, that means that all the angle measures equal each other. So this is an equiangular triangle, and in an equiangular triangle, every angle measure equals 60 degrees. So x is 60 degrees. We will go ahead and do example 7 and then stop. I will finish this last page of the notes with you when I come back on Thursday, but let's look at example 7. Again, we want to find the value of x. We're going to add up the 3 angle expressions. The one with the box, or the square, remember, that's 90 degrees, so its expression is 90 degrees. We have to add up all 3. You don't want to just add up 2, add up all 3, and that equals 180 degrees. So we've got 90 plus 3x plus 2 plus 2x plus 3, and that all equals 180 degrees. So let's go ahead and add this together. If we combine our like terms, our x's, we've got 3x plus 2x, which makes 5x. If we combine our constants, we've got 90 plus 2 plus 3, which makes 95. And those add to make 180. Subtract 95 on both sides. $5x equals 85. And then when we divide both sides by 5, we get that x has a value of 17. Now again, that's just solving for x, but a lot of times I'll have you go back and plug them in. I could have you plug it in for angles J and L to figure out what are the measures of those two angles. If we kind of do it in our head, look at angle L, 2 times x plus 3. If we plug in x with 17, 2 times 17 is 34, plus 3 would be 37 degrees. And if we were to plug it into angle J, 3 times x plus 2, 3 times 17 plus 2, what's 3 times 17? 51 plus 2 would be 53. Notice, the two acute angles in a right triangle, angles J and L in this case, will always add up to 90 degrees. These two will always add up to 90 degrees. And you can verify that right now. These two add up to 90 degrees. Because those two have to add up with this other 90 degrees to equal 180. So if you do have expressions for the acute angles in a right triangle, you could make another equation or a different equation instead of the one we made, where you're just adding the two acute angles and having those equal to 90. So you could have done 3x plus 2 plus 2x plus 3 equals 90 degrees. And when you solve that, you're also going to get 17 for x. Just make sure that you understand the difference between those two equations. One adds up all 3 angles to equal 180. One adds up just the 2 acute angles to equal 90. Don't get those mixed up. We will finish the rest of this in class. You will now work on the practice. That will be due next time. Remember, if you had any questions over the notes, please, jot them down and make sure to ask me at the beginning of class next time. See you Thursday.